First off, you need to go ahead and read through example 2 if you haven't already done so. You can go ahead and pause the video now if you need to. Now let's go ahead and check out part A. They gave us information for this problem in terms of words. And what they want us to do is write down an equation that represents those words. So first off, I noticed that we talk about cost. And the author has asked us to use capital C to represent cost. And then, once I have that, I have to see then that there are in fact two different costs that are being described in this problem. We have a variable cost that depends on the number of miles that were traveled, and then we also have a fixed cost that doesn't depend on the number of miles that were traveled. So let's go ahead and start by talking about units, and then we'll go ahead and talk about both of those pieces. So you'll notice we have 75 cents per mile, and then we also have $5. That means that we have two units running around in this problem right now. We can't have that. We have to have one unit for the problem. So I have to make a choice and say everything's going to be written in terms of cents, or everything's going to be written in terms of dollars. I'm going to go ahead and choose to write everything in this problem in terms of dollars. So let's go ahead and start with that 75 cents then. Well, in order to convert 75 cents into dollars, I need to move the decimal point 2 places to the left. So 75 cents is equivalent to $0.75. Now, 0.75 is the start of my variable cost. So for every mile that was driven, we're going to have 75 cents added to our cost. So what we have to do then is figure out how to make that variable cost work. Well, I need to multiply 0.75 times something, and in this case it's going to be the number of miles, n. 0.75 times n then, every time I change the n, I'm going to have a new cost for this particular problem, and that's why this is called the variable cost. Different n gives me a different cost. But I also have the fixed cost, and that fixed cost is in addition to what we've already paid. So we have to pay $5 just to get into this ride-sharing vehicle, and that's our fixed cost, so we're going to add that to the end. So there we have our equation for this problem. C is equal to 0.75n plus 5. Now that I have an equation, there are lots of different things that I can do with that. In part B, the author has asked us to graph this. But he didn't ask us to graph it in any old way. He said he wants us to graph this up to and including 50 miles traveled. So let's keep that in mind as we draw this graph. So first off, I'm going to say that C equals 0.75n plus 5 is in slope-intercept form. And because it's in slope-intercept form, this 5 at the end is my b value. And that's going to tell me the y-intercept of my line. Well, my y-intercept is going to be the 0.05. So I'm going to go ahead and plot that 0.05 on my Cartesian coordinate system. Now, this once again is written in slope-intercept form, so I can also read off the slope. So the slope of this line is 0.75. Now, if I tried to force slope to be a decimal, that becomes really difficult down here. So thinking back to things we did last time, one thing we could do is rewrite 0.75 as a fraction. 0.75 is 3 divided by 4. And once I've rewritten it as 3 divided by 4, then I have a rise of 3 and a run of 4. I could use that to find a second point on my line. However, because of the tick marks that are being used here, that isn't necessarily going to work nicely for this particular problem. So instead of coming in and trying to force this to be a slope problem, I can also simply go in and find a second point. And because the problem asked us to come in and think about what happens when we drive 50 miles, let's go ahead and just find a point that's associated with those 50 miles. So 50 is going to be our n value. So let's go ahead and plug in an n value of 50 into our equation. So we're going to have C is equal to 0.75 times this n value of 50 plus 5. 0.75 times 50 is going to be 37.5. And if I add 5 to that, I'm up to 42.5. Now, there are two different ways that I'm going to play with this 42.5. In a moment, one way that I'm going to work with it is to think about it as a point. But before I go there, I also want to think about the fact that C represents cost. So cost in general is going to be measured in dollars and cents. And because it's dollars and cents, it makes sense to go ahead and round to 2 decimal places and then throw in a dollar symbol on that one. So what this is telling us then is that if we drive 50 miles, the cost is going to be $42.50. But again, that also tells me a point on my graph. So it's going to be the point 50, comma 42.5. Well, 50 on the n-axis, 42.5 on the c-axis is going to be halfway between 40 and 45. So there we have 42.5, and that then gives us enough to draw our line. However, again, because of the wording that the author used, he said that he only wanted us to draw this line up to and including this 50. So what that's saying is he wants us to draw a line segment. He simply wants us to go from the y-intercept up to this point 50, comma 42.5, and just stop. He doesn't want us to continue and to have a line that goes forever. He simply wants us to write a line segment. So we're done with part B. Now we're ready to check out part C. Now part C is asking us to simply come in and plug in a different value for n. So this time they're asking us to plug in an n value of 40, so we can do that. We'll have C is equal to 0.75 times 40 plus 5. 0.75 times 40 is going to give us 30. Add 5 to that, and we're up to 35. Once again, this is representing money, so it's going to be dollars, so we'll throw in that dollar symbol, and we have an answer. The cost for driving 40 miles is $35. Now, when you look at part D, you have to be kind of careful. Be aware that they haven't given us an n value this time. This time they gave us a c value. They gave us the cost. So we need to come over to our equation and just plug in the cost for c. So, okay, let's do that. They gave us cost of 27.5, and that's equal to 0.75 n plus 5. So this time, we have a linear equation that we have to solve. So let's solve the linear equation. I'm going to start by subtracting 5 from both sides. 27.5 minus 5 is going to be 22.5. And then I need to divide both sides by 0.75. If I divide both sides by 0.75, I'm going to get 30. So n is equal to 30. Now, once again, because this is an application problem, I should always think about units. So n is talking about the number of miles that are driven. So let's go ahead and put that unit on there. So there we have our n value. So this says that if we have a cost of $27.50, we had then 30 miles that were driven. At this point, you are ready for the homework 28. So have fun with that.